Hi guys, let's continue and so let's solve the next question. Let's take a look. So the next question called sum root of leaf numbers. So we are given a root of binary tree that contains digit from 0 to 9, and each root to leaf path in the tree represents a number 1, 2, 3. For example, the root to leaf path is represent like 1, 2, 1, 2, and 3. So represent number 1 to 3. Return the total sum of all root to leaf numbers. Test cases are generated so the answer fit 32-bit integer. A leaf node is a node without node children. Okay. And here we have 495, 491, and 40. Okay. So actually what we can do, we can, for example, generate some strings and then just parse them and just parse them and concatenate. Another option, when we are on the leaf, we can return, for example, 5, and when we return 5, then we have 9 here, right? Then we have 9. Like 5 multiplied by 5, 9 multiplied by 10. It would be 95. And another one would be 1 plus 9 multiplied by 10 also. And we actually return this sum from here. And so we return this sum, 95 and 91. 40 returned from here. And from 90, we should also return 2 options, right? Okay, so let's try to make it simpler and just store as a string. So what we do, we have a set of string, and we have DFS, where we populate this set, and we have also root, and then what we do, we just go how it would work. So we have 4. When we call 4, we send this 4 to 9. We concatenate 4 plus 9. Then we send this string here to 5. And also concatenate it with 5, but 5 is actually a leaf. So we just set it to the set. So we have also empty string. And then we have value like string value in our set. We can get like integer parse int value. And we have integer result. And return result. And we have our set, our DFS call with tree node with string and set of strings. When node is equal to null, we just return. If node left is equal to null and node right equal to null, so it's our children, then we just do like set add string plus node val. Else else we do two calls for DFS. First would be with node left, string plus node val, and set the same one for node right. Okay, so let's run it. Okay, accepted, so let's submit. All right, so we have 2, 0, 0, and output 2, 0, but we expect 4, 0. What does it mean 2, 0, 0? Let's put it here and run this test case. Here we have this beautiful thing. Okay, so when it's 0, we put like 20. Okay, so it should be probably not the set, but at least. All right, so now it should work. Run and submit. Okay, so it works, but it's very slow. So actually, I think that probably we need to do something different, not with string concatenation, but with another option. So I believe we should return list of integer, and it will be not string. Here will be not set, and here it would be a list of, so it's empty list. When it is the last, when it's the last one, we should, we should, I think, return new array list. And here it should be list of node value. Then we are doing two DFS calls. First for left and for right. But also we need to understand on which level we are currently. So when we return from DFS, we have, for example, here we have 5, right? 5. And currently we are on 9. So we should return from here like pair, I think, pair of integer and list. And this pair we can create, or can we have this pair? Yeah, for now, let's just do it. So new pair, where we have one, and here we get our pair of integer and list to the left. And the same pair we have with right. And now what we should do, we should create another list. Call it result. And like for every I think like level, we can also correspond like level, and level would be the following. So if left not equals to null, or it will be never null. So if left here, it should be, let's call it null. So if left is not equal to null, and right not equal to null. So if left not equal to null, then we take from left first element. Otherwise, we take from right first element. Okay, and then we do like level multiply by 10. So it would be like our next level. After this, we should, we have our result. So we get integer left values, left second, and result add LV. So here it will be like 5, but here we have not val multiply by level plus LV. And the same thing we are doing for right. And here we can check like if left not equal to null, we are doing this thing. here if right not equal to null, we are doing this thing. Okay. And what next? What next? Left and right. Result. So, okay. And here we return new pair. This one with level and the result. And we call this actually DFS from here with root. We are getting this as our result. And what should we do? We should have our result, and here we just do like pairs. Second. Here we have integer value and result plus value. Let's run it. So my main point, do we have this pair actually or not? So we have completion error. Here we should get new. All right. Here we have pairs. Second, variable second. Okay. So we have at least one node. Okay. Let's create this record pair, and pair would be with key value, and we have k first and v second, something like this. Okay, so what we have, second has private access in pair. Okay, private access. What if I use my pair, for example? And yeah, instead of this pair, I will just use my pair, and that's it. My pair. Let's try it. Second has private access in my pair. What does it mean? So we have pairs. It's my pair. It's record. What if, I don't know, my pair was integer first, second. Yeah, I don't understand why. Let's try not with record, maybe with class. So we have class, and we have two two public fields here. Or I think even we don't need this public. We can have something like this. And also we can have a constructor myPair with k first, v second. And here we just initialize first, and this second equal to second. Let's run it. Okay, so now we have LV. Result, it's our list, and LV. So we again we have LV. So here LV. Okay, so first one is correct, second one is not correct. So we have 1,386 49. Yeah, let's take a look what I'm interested in, like what pairs we have here. So we can just system out println. We can print left, something like this, and here we can print right. Okay, so we have left 5, then 1, then we have 95 and 91, correct? 95, 91. Then for 95, we have 4, right? So when we call 4, our level would be with 400. So it should be like 495 plus 491. From the left, we have 0. Okay. Okay, and let's also print our result. We can print our result. It will be result pairs. Okay, so we have 495, 491, but we see that it's not 40, it's 400. So this left and right, it's not correct. So we should have right level and left level, actually. So but when we here, for example, and we return from here, what level should we return? Like maximum. So I think we should return different levels. So that's the main problem. It should be not one level. So here return 1, but yeah, but then we have this left and right. Yes, and we should return different levels. So yeah. So it should be like list of pairs with different levels, so it's more complicated. Let's just check editorial and solutions. Okay, a recursive solution return 0 if null return s multiplied by 10 plus n value. Then we call it like this. Yeah, I think this may be even easier. Yeah. So what we can do, we have our sum. So no, this one is not. This one is better one. So we have our sum. If it's null, we return 0. If it's our leaf node, we have our sum, and we multiply it by 10 plus n plus value. In the leaf node, it would be 0. So we just return this value here. Yeah. And here we just, yeah, adding this sum together. So I'm thinking, like, do we have this sum more than 0? Yeah, this one is interesting. Okay, so that's it for today. Thank you.